Hi, I'm Bruce Momjian, Postgres core team member and EDB vice president. It's a pleasure to be speaking to you today at the Postgres and IvorySQL Eco Conference. I would love to be in Jinan today. I would be super excited. I haven't been in China in too many years. Unfortunately, I was already scheduled to be at another conference during these same dates. So unfortunately, I'm having to speak to you virtually, and I do apologize for that. But I do have the pleasure of speaking today with really an interesting topic. When I started with Postgres 29 years ago, these two strengths of Postgres, it was not really clear that they were going to be something that was going to propel Postgres to the kind of success that it has today. But what's happened during those 29 years, and even Postgres source code goes back even farther, 39 years. During that whole period, the two strengths of Postgres, the open source nature of its development and its extendability, have become more and more important as the years have progressed. I really didn't even anticipate that these would be so important. But effectively, the way that history has played out for those 29 years or 39 years has put Postgres in a unique position in offering solutions that pretty much no one else offers. And that's why Postgres is really sort of the undisputed leader at this point, the only relational system that's really growing in terms of adoption and features, and certainly a project and a piece of software that has many, many years of success ahead of it. So what I'd like to do is talk to you today about the open source development process and extendability. You may not have thought of those as defining aspects of Postgres or something that really sets it apart. But as I describe these features, I think it will become clear why these are just so critical and so important to not only the historical strength of Postgres, but the strength of Postgres going forward. This slide, I really kind of love this slide, and there's some history to this. When I started with Postgres, we were kind of at the bottom of that red line. So our features, our performance, our reliability were inferior at that time in the late 90s to the closed source databases. But one thing I realized is that if we had a steeper curve of improvement, we were growing quicker, we were getting features faster, we're getting performance faster, we're getting reliability faster than the closed source options, eventually we would pass them. Now, at that time, late 90s, we only had a couple hundred users, small development team. So it really wasn't clear that we were going to surpass anybody. But what happened during that 29-year period is that effectively we did continue to grow. We continued to have people excited about our technology, not only as users, but as developers. And we continued to accelerate our improvement in a way that could not be matched by the closed source companies, no matter how hard they tried. So effectively, where we are today is we have superior features, superior performance, superior reliability. Again, probably the only relational database that's growing, and Postgres has a very promising future ahead. It's kind of surprising. I didn't expect that. Obviously, when I started, I just thought it was something interesting, something that had potential, something that could serve the user base that we had. But it's grown clearly far beyond what I expected. Although I suspected again that we would continue growing faster than others, but the fact that we've been doing it for so long is pretty astounding. So, what is it about the open source process that is critical to Postgres' success? And the best way to explain that is to look at the non-open source way of developing software. The way the closed source companies develop software. And in the closed source development process, you effectively have the development team, which are inside of the company on the left here, and you have the users, which are on the right. And all the development, because it's closed source, happens on the left-hand side. And the users really have limited visibility into what's happening on the right-hand side, right? When the development starts on the left-hand side, you start with design meetings, and then you work in isolation, right? And then you have project meetings over here. And then you do testing, and then finally you release the product, which goes over to the users, and then they have to go through their process of testing and acceptance and resolving and installing and going to production. And then once they have a problem, it goes back over to the company, usually through some kind of sales channel, or technical support, and goes back in design meetings, and then basically loops around. This is an incredibly inefficient system. The surprising thing is that billion-dollar companies who write relational databases cannot produce software as good as Postgres. Not because they aren't trying, not because $1 billion isn't a lot of money, but effectively this process is so inefficient that they effectively can never really get the kind of momentum and quality and sort of design for very highly complex systems that are also very easy to manage. It's just really hard to do in this very clunky, very awkward situation. So developers who are on the left-hand side, they're so disconnected really from the users that it's just a real challenge for them to do almost anything. I've heard some stories about closed source development and how hard that is, but it's just a very difficult process. And again, no matter how much money you have, no matter how many people you throw at it, the process itself is inefficient, and therefore you really can't kind of break out of that problem. In open source development, we do not have those kind of inefficiencies. As you can see here, all of the development activity is visible to the users. Users can be involved to whatever level they wish to be involved. They can be involved in feature design and patch review and testing, beta testing, production, and so forth. And this process is so efficient, not just for Postgres, but you look at pretty much all the infrastructure software that is being used today. It's pretty much all open source. Again, not because there aren't billion-dollar companies trying to produce this software, but effectively very nimble teams, very efficient teams are able to create software that's far superior to the closed source software that most companies produced up until open source became popular. So again, this is not unique to Postgres. Postgres does this very efficiently. We have a very robust community development process, if any of you have been involved in that. But again, this is the key aspect of what makes Postgres what it is, why it can produce better software than billion-dollar companies. You would think that is impossible, but in fact, we do it, and we do it very well. So let's step back a little bit, and I really do love this slide, and understand it from a user perspective. Okay, a user kind of has been using closed source software for a long time, and they decide, I want to be involved in I want to try open source. I've heard a lot about it. Why would I do this? Okay. And if you see the blue text down here at the bottom, that's a URL for a survey that was actually done by Black Duck Software. And what was really interesting is that the companies who chose open source, their number one reason for choosing open source initially was cost. So the concept of a less expensive solution was really, I think, is usually the driver of what gets people interested in open source. But what's really surprising when you look at this slide is the fact that the cost is number 5. And the reason the cost is number 5 is this list is not from when they originally chose open source. This list is from 2 years later. So what happened is that they originally chose cost as the reason. But when you come back 2 years later and you say, now that you've used open source for 2 years, is cost still the number one advantage? And in fact, it's not. Innovation and competitive features are the number one reason people choose and companies choose open source today. That may not be their initial number one reason, but once they get used to open source, that is their effective reason for continuing to use it and continuing to use it more and more. Second reason, freedom from vendor lock-in. Okay, the ability to effectively not be locked into a specific piece of software. In fact, IvorySQL, that's a good example of an open source project that reduces lock-in because it gives you Oracle compatibility. It's kind of cool. You're using Oracle syntax, but you're not using Oracle. Kind of an example, I think, of that lock-in for open source. Number 3, quality of solutions. The idea that open source quality is very high and higher, again, than the software produced by these billion-dollar companies. Number 4, ability to customize and fix. That's a big one. And then number 5, again, is cost. Not that cost is not an issue, but it isn't the driving issue anymore. It may be the initial driving issue, but it is not the driving issue once people get experience with it. Then, of course, other things like speed of application development, reduced development cost, interoperability, breadth of solutions, all key aspects of why people choose open source. Now, you may be thinking, Bruce has been dealing with open source too long. He's kind of he thinks it's fantastic. What proof do you have that this is actually a thing, that what I'm saying is accurate? Well, in the 90s, when I was an application developer, the big 3 operating systems for enterprises were HPUX, AIX, and Solaris. Now, I'm a little embarrassed. I'm sure there's people in the audience who have never heard of these operating systems. Okay? These were the big operating systems in the 1990s. But what happened to these operating systems is they were all run by billion-dollar companies, okay? But they were all closed source. And Linux came along and FreeBSD came along, and effectively no one is using these. Solaris is end of life. I think AIX still is around. HPX, I think, is no longer being developed. So again, huge projects, huge operating systems run by billion-dollar companies in the 1990s. You've probably never heard of them, or you certainly don't know anyone who's using them, at least for new projects, which would be unheard of. Because again, all of the operating system work has shifted to open source. And obviously we're seeing now all of the database work shifting to open source. Because again, Postgres is just one part of a much larger open source software ecosystem that, we're all part of, and we've got a lot of activity there, but again, we're just one piece of that. All right. Another example, okay. When in the 90s, the big databases were Oracle, DB2, and MS-SQL. All right. Those were kind of the big ones, right? They're still around, but again, nobody's really deploying probably brand new on Oracle. DB2 certainly not. MS-SQL, yeah, it's kind of nice. It's integrated with the operating system. It's kind of good for departmental work. There are probably some people deploying with that. But 4, 5, and 6, these were big ones. Sybase was huge in the 90s. Informix, I was in Informix user in the 90s. A lot of my clients used Informix, and they also use number 6, Ingress. Again, this is a great example here. These companies are either not either end of life, or they're effectively on the decline in a big way. And again, this is sort of proof, as I was saying, that the industry has shifted so strongly to open source. Not necessarily because they love open source. Yeah, they maybe philosophically some people do. But effectively, the big switches happen because open source gives them an opportunity that they don't have with other pieces of software. And again, I've shown you why that process, the development process, is so efficient and so powerful. And effectively, that is what has driven Postgres and other open source software to become key parts of most enterprises. Now, if you're interested in more information, I have a URL here, momjian.us. One is Will Postgres Live Forever? That's a longer talk about open source process. And the second one is Democratization of Databases. Again, it talks about how open source really propels creativity and sort of magnifies everyone's intellectual capabilities and harnesses their intellectual capabilities in a way that can't really happen very easily inside of companies. But in open source, it works really, really well. And again, I encourage you to take a look at those. We'll have a QR code at the end you can use. There's one more aspect of open source, and I just wanted to kind of throw that out there because it's become more important in the past year or two. And the reason is because the global economy has become much more volatile than it was, for a long time up until now. We have tariffs, we have sanctions on countries, we have embargoes, and even wars, which is sad to say, but the world is a pretty chaotic place right now. And a lot of companies, a lot of enterprises, a lot of countries are starting to think, where am I? Where am I? What software am I relying on? Am I going to be able to get that software in the future? Is it something that could be embargoed against me? Is it something that could basically cripple either my enterprise or my country because I can no longer use it? And for software that's developed outside of the country, typically in the United States, that's a big deal. One of the nice things about open source, and particularly Postgres, is that it isn't tied to a particular country. It's a global project. It has no specific governance in any one country. So there really isn't any way to sanction it. There's no way to sort of embargo it or anything like that. For example, Russia, when they got in trouble with Ukraine back in 2014, I believe, there was a lot of sanctions put against the country, and Russia decided to get very serious about Postgres. They developed their own Postgres industry and those Postgres expertise, and they and they're successfully using Postgres today. I'm sure other countries, including China, potentially could get in that situation. But again, as you're seeing with a lot of these companies that are grown up in China, standardizing on Postgres, getting very serious about Postgres, getting a lot of expertise from Postgres. I know some of the high-go blog posts are about, like, for example, the optimizer are amazing. So again, I know there's some really smart people in China doing Postgres work. And again, one of the great things about Postgres, you can be from any country, it doesn't matter. You can participate this exact same way, no matter what country you're from. So again, I have a blog at my website called Geopolitical Postgres if you're curious about more details. But again, this is another aspect of open source I think is quite unique, the ability or lack of ability to have it restricted, like a particular, a proprietary piece of software that could happen. So I'm excited about that. That's one of the reasons I travel so much, to basically talk to so many experts we have all over the world. It's a very exciting thing to do. The second thing I wanted to talk about, and the second real, I think, key part of what makes Postgres what it is extendability. Now, extendability, I'll admit, when I started in 1996, it was not something I thought was a huge thing, a great thing. It was kind of annoying to us. It made Postgres more complicated, made the source code more complicated. But it actually was designed by Michael Stonebreaker in 1986. Remember, I said the Postgres source code is 39 years old. When we started in 1996, we just kind of ignored it. And frankly, extendability really didn't become a defining part of what Postgres was, except in the past maybe 12, 15 years. And it's accelerated, as I said in my introduction. The importance of extendability has gotten more and more important for Postgres. And I'm going to explain why. And it's somewhat surprising. First off, how does Postgres do extendability? Well, when Michael Stonebreaker designed Postgres in 1996, he decided, 1986, he decided what he was going to do. He's going to create some system tables here on the right. And he was going to create not only the traditional system tables where we store usernames and database names and column names and table names and so forth, but he was going to create tables that represented indexing types, tables that represented data types, tables that represented aggregate types, functions, tables that represented server-side languages that you could install. So all of a sudden, you had a system that was not locked into specific data types and specific languages and specific indexing methods. And what you had was this effectively object or relational plus, we'll call it, which basically extended Postgres it allowed Postgres to extend in so many different directions. Now, the first 10 years we worked on Postgres, we weren't really thinking of that. We're just like, okay, we want a relational database that works as well as the proprietary database, the closed source databases. But what shifted is that as people's needs changed, this extendability became a key aspect of what made Postgres what it is. Remember, I said that we had, a long history of Postgres. Here on the left-hand side, started in the university in 1986. I started in 1996, and the first couple of years we just were preventing it from crashing. And then in 1998, we started on focusing on the SQL standards. I'd say 2001, we started on enterprises. But what's kind of interesting is that in the past 13 years, we've been focusing on innovation. And what's really interesting is that we can do standards and we can do enterprise features, but what we really do well is innovation. And I think that is one of the key aspects of where extendability came in and really sort of changed how Postgres is viewed in the market and gave Postgres a unique capability that really no one else could match. So why was extendability so important? What was it that did that? Well, when I was working in the 1990s with relational systems, we were focusing on like order entry stuff. So we had character terminals, and you would type in orders and parts and invoices, and you'd send bills, and you'd run financial reports, all very sort of online transaction processing, as they call it, very, very column oriented, a lot of calculations, pretty straightforward. And during the late 90s and early 2000s, data warehousing became big. So you start to have these big Teradata, Netezza kind of big data warehouse systems. But what has happened in the past 13 years or 15 years is that data storage has become much more diverse than it was when I was an engineer developing applications in the 90s. So looking around the circle here, we started collecting web browser data that we would put in the database. We had mobile apps that needed to access data. We had Internet of Things, obviously, that was recording data. We have AI that we've been working on. Obviously, that's a hot topic. documents people wanted to store, GPS, GIS data, social media data. So the traditional storage for relational systems, order entry, that's kind of blown up, where we now have a whole bunch of different things people want to do with that data, and a whole bunch of things people want to store in Postgres using that data. And effectively, because Postgres is extendable, it's allowed us to say, oh, you need web browser data on mobile apps? We'll add some JSON types. Oh, you need AI? We'll add PG vector. Oh, you have documents? We'll do JSON. You need GPS data and GIS? We'll do PostGIS. So what's really interesting is, as these needs came, Postgres already had the extendability, and we could all very easily add a very seamless addition to handle the new data types that people were needing to use. And I think that's really the defining thing of why extendability. I think if the data needs hadn't changed, honestly, Postgres wouldn't be where it is today. Because today, a lot of relational systems try to do this, but it's very hard to add extendability to a relational system that doesn't have it. Postgres had it for years. We left it in. We didn't change it. But what happened is that the market changed while we were developing Postgres, and the needs for this diverse ability to store data became more and more important. So when you look at Postgres today, you have extensions up here to the top right, PostGIS for GIS data, PLR for data and analytics. Over here, we have JSON for document storage and for mobile apps and web apps, phone apps. Then down here, we can do data warehouse. We have window functions, data partitioning, bitmap scans. Again, that was very easy to add because of extendability. And then also, if you don't want to use extendability and you actually want to store your data somewhere else, you can use foreign data wrappers that allow Postgres to reach out, bring in data, and then bring in maybe data from multiple systems, process it in Postgres, and then return the results to the user. So again, if the first three here are not enough for you, we have foreign data wrapper control. Over 100 different data sources are possible, different data, what we call foreign data wrappers, which interface to different data repositories effectively, and allow you to pull that data from that repository into Postgres, process it in Postgres, and then send it to the user. If this is interesting to you, this extendability, I do have a presentation called Making Postgres Central in Your Data Center, and it does go through some of the system tables. It explains how you install extensions that add features to Postgres, and how you can effectively use that with our document store, the JSON, do data warehouse of Postgres, and then foreign data wrappers. And it kind of gives you a full panorama of what that extendability is. People sometimes ask me, what do you think the next extendability need is, or what's the next data? I don't really know. We never knew before these things showed up what was needed. I have an AI talk on my website. Generative AI is only 2 years old, 2.5 years old, but it has grown tremendously. Fortunately, when generative AI came along, somebody had already developed PG vector. It was already existed. So when people want to do generative AI, we're like, okay, no problem. Just download PG vector. It's already there. You add it to an existing Postgres install. All of a sudden, you're doing AI with it. So again, surprising, we didn't really plan on being a huge AI database. That's just an example of whatever our extendability has allowed us to do. So that does complete my presentation. If you'd like to look at these slides, down here at the bottom, this is my website. Here's a QR code here on the bottom left that you can use there's, I think, 62 presentations on that website, over 130 videos, 2,800 slides, and I think almost 700 blog entries about Postgres. So a lot of stuff there. It has been a real pleasure talking to you again. I would love to be there with you. I hope I'm going to be there the next time. I looked at the schedule. It looks really interesting. The city looks interesting. The hotel looks great. Your talks look really good. I'm sure you're going to have a wonderful time. Thank you for spending time with me. And I hope you have a wonderful conference. I'm sure you certainly will. Goodbye.